we've got the mass of Captain America's shield, 5.4 kilograms. This was looked up on Google, so it's definitely right. We have the starting and ending velocities of the shield. And I'm just going to make sure that they are in the same direction. So the one that's south, I'm going to write it as negative 45 meters per second north. So we actually can figure out the starting momentum and the ending momentum just with that. We're also told the time of the impact between the shield and the bad guy is 5 milliseconds, which I'm going to convert to seconds, divided by 1,000. We have to find the force. So this is almost like a classic impulse momentum theorem type question. You know the change of momentum. Okay, I said that earlier. You know both momentums, so you can find the change of momentum. And what does the change of momentum equal? It equals to the impulse, the net impulse. So here, I guess we're assuming that the shield is the only force. The shield is the only force on the bad guy that doesn't cancel out, like gravity and normal might cancel out. So the shield's force will end up being the net force. I guess we have to pretend there's no friction too. Yeah, that's an assumption we gotta make here. Which might actually be true. If the shield completely knocks the guy off his feet, then his feet's no longer touching the ground and there's no friction. All right, anyways, we will use this formula. So P2 minus P1 will be force times time. I think that's the formula for impulse, is force times time. We're solving for the force, so we're dividing both sides by the time. I can change the momenta to MVs. Divide both sides by time. That'll give us the force. So I'll fill that in, 5.4 kilograms times negative 45 meters per second minus 5.4 kilograms times 50 meters per second divided by 0.0050 seconds. That'll be the force. Put that all in the calculator here. Okay, so I'm getting negative 1.0 times 10 to the 5 newtons. That's a whole lot of newtons. The direction would be north, because those are the directions I had in my given information. So negative north means south. So the shield applied a force on the bad guy at 100,000 newtons south. So Captain America, very strong. Actually, a correction here. This net force we calculated, this was calculated for the shield. So this is actually the net force on the shield. That's what the bad guy did to the shield, actually. So what did the shield do to the bad guy? We go to Newton's third law. It applied the same amount of force, but in the opposite direction. So therefore, the force on the bad guy is positive 1.0 times 10 to the 5 newtons north, which makes sense. The shield was going north, so when it hits the guy, it should apply a force in the north direction.